TV. But anyway, Facebook and eBay, thank you very much for keeping my kids so busy so that I can get some work done. My daughter likes you the best. My son likes you the best. But I want to say this, that I got a question for you, Jay. I'm going to get down to business. You guys were able to turn down your crack units because you proved that you could live with less air capacity than you had designed for. And you chose to turn off crack units. Did you consider using VFDs? You know, the fan performance curves in VFDs will allow you to save, again, twice as much as as you do if you turn off crack units.
Absolutely, we looked at it.
Okay.
So unluckily, the VFD, the cost of the VFDs wasn't cheap. So when we did the ROI study on this, it wasn't looking so nicely. That's why we chose to go the other route and just turn it off. Absolutely, you're correct. I mean, I love having the VFDs and ramp it all down and have a more constant static pressure and the airflow. That's all good stuff. But
exactly. It depends upon how far you can turn it down. And let me explain to everybody that if you're using VFDs, you're not using it to drive the fan speed up and down to follow the load of the data center, but you're turning all of your fans in your crack units down a certain percentage, and they continue to operate at a constant speed.
That's correct.
But the fan performance curves allow you to save a cube of what you turn down your speed. So if you turn it down to half speed, the energy goes down by a half times a half times a half, which is 1/8. And you save a lot of energy. But you've got to be able to turn down those fans significantly in order to get there.
Yeah. A good number I like to use is that a 20% reduction in fan speed equates to a 50% reduction in the actual electrical energy at that motor.
And a 50% reduction in fan speed results in a 75.
That's right.
Actually greater than that, about an 80% reduction in energy.
And the interesting thing is that we all have redundancy of mechanical equipment. So as we have a redundancy of either crack units or crawl units or something else, right? Because we have redundancy, we can always reduce those units down, unless we're somehow running at overcapacity, which is never the case. So in these cases, and these are great examples, right? In all cases, you actually regain back capacity, you saved energy, right? And you did, instead of adding the VFDs, because that was more costly, you decided to really do a step function, just say, let's just shut off, the crawl units on or off, which when you have, was it 19 of them, I believe, in the space you said you had? Right, so 19 of them I shut running off is kind of like a 5% reduction with each one you shut off.
Bruce? Now, I've got a second question.
Hang on.
I just wanted
you can ask me a question.
Follow up with that. And actually, understanding how many Cray units Facebook was dealing with, but we looked at a similar thing, and this was actually a next step. So all the things that I discussed in my slide presentation were all prerequisites to next steps, obviously. And there's still things that we're working on and continuing to do to increase our efficiencies. But I'm dealing with 86 30-ton Crays. So we did install variable speed drives and are in process of doing that and linking that to our BMS system through wireless controls, and look forward to seeing the same type of savings that you're discussing. We also worked with our utility provider and through their energy incentive programs helped to reduce our ROI. So we're looking at about an 18-month ROI on 86 30-ton Cray unit VSD installs. So.
Did your utility offer you an incentive to make that change with VFDs, Jay?
They actually gave us, we had a fixed amount.
Okay.
So we got, as I mentioned, that we got like $300,000 the rebate check. We were just maxed out on that one. We couldn't get anything more.
Projects that I'm working on in California, the incentives that the utility pays makes it a realistic project, whereas it might not be elsewhere. Right. Now, I had a second question, and that is...
Make it quick so we can get on some
I
other
had three questions, but Pepe took one of them, so... Let's see here.
I figured that was the case.
All right, you guys turned down your server fans. That's very interesting. Did you track your PUE? Did you realize a reduction, or not a reduction, but an increase in your PUE? Penalize your PUE as you saved energy by turning down the fans, because that really is part of the IT load. So if you brought down the IT load, that would show an increase in the PUE. You'd effectively be penalizing your performance, but you're really doing the right thing by turning down the total energy you used.
Yeah. That's why, from our slide, took that PUE numbers out, because while we were doing this test at the project, the load was actually, we were installing cabinets. We had too many moving variable numbers there. The load was increasing. So it was very hard to measure the PUE. PUE is good when the load is constant, but in this case we had the two moving numbers. So it was very difficult to measure. But so at the beginning of the project was, as I mentioned, there was about 1.87. And after the project was done, all the load was increased. We were at 1.58.
And this brings up a great point, is that we shouldn't focus entirely on PUE. We should be focusing on energy savings and money savings, right? That's what we're all about here, saving energy. Right. Yeah, because we want to save net energy, even if our PUE doesn't necessarily go down by as much as we'd like, or even doesn't go down at all. If we're saving energy, that's the key.
Unless you want an Energy Star. But well, I agree, that's the
that may be true. And also, as a good just kind of notice, is that later on today, there's also going to be a discussion, I believe it's right after lunch at the 1:30 time period, on the agenda. It's going to talk about the new revised PUE metric, which now takes into account annual energy use instead of just a one-time power use, which is a far better metric to have. It's what I've always been reporting all of my PUE measures on for years now. I think it's the right way to do it. So we're going to have some folks talking about that, as well as a new lead for data centers, and as well as also revised Title 24 standards, which will focus on data centers. So for those of you that have data centers in California. So I just want to kind of throw that out there. That'll be a great session to attend to follow in that conversation. Bruce, thanks for your discussions. Actually, you already have the mic, sir, and then we'll get to Prajesh. I'll get to you next, okay? Thank you. Yes, sir.
Yeah, Larry Vogan with IBM Corporation, working on Kaiser outsourcing contract. I think this is primarily for Facebook. What considerations did you, being as how you have a fully enclosed cold aisle containment, what considerations did you have with the fire department and codes and et cetera?
That's a really good question. So our cold aisle has the fusible links. So if there is any fire in that cold aisle, it'll collapse. So the sprinkler heads would not be in the way. Okay. Another thing that, personally I don't like cold aisle containment. The reason behind that is because when you walk around the data center, it's hot, right? So I don't like that, but yeah, we did look at that, and the cold aisle containment, all those panels that we installed, it's got a fusible link, and anything else?
They are fire-rated panels as well.
Yeah.
So all the material that goes inside the data center is fire-rated, as well as we invite fire marshals to do walkthrough. We go to them with our proposals, have them sign off on that, and then only we go ahead.
And if you like, we can actually share that, all the panel spec and all that stuff for you. So, yeah.
Yeah. That's great. Thanks, and that's a great question. And in the projects I've worked in, there's a lot of both soft, meaning like strip curtains, as well as hard panels, and they're designed specifically for data centers. So they're non-combustible. They meet the fire rating specs. They do have the fusible links. Some fire marshals are still leery or skeptical, so it does take sometimes a little bit of effort working with them. But there's plenty of manufacturers, fortunately, make some great air containment products for the data center nowadays. And the warm temperature thing, that's interesting, that is often interesting thing, is that we talk about data centers always being cold, but they don't need to be, right? The servers can have quite warm temperatures. And so it's really just humans that generally like it a little bit on the more comfortable side. So that often does drive sometimes where we kind of limit those temperatures of what we're comfortable working in. Prajesh, you had a question. Let's take yours.
I'm Prajesh from Lawrence Berkeley National Lab. Question for Facebook. How did you solve the zone of influence for the cryo units?
Okay. So at that time, we created CFD models, and we ran number of scenarios while taking each cryo units off, setting that as off, and see what pressure distribution we are getting underfloor, and then based on that pressure distribution, what airflow would we get in each cold aisle, because each perf tile has its own curve depending on underfloor static pressure, how much flow you are going to get. So that's how we estimated it. Now, when we do measurements, they don't exactly match, but we were within 10% on those predictions, and that's how we ran.
Great, excellent. Are there any more questions from the audience? Oh, wow, there's quite a bit. Okay, sir, I'll take yours just because I saw you first, and we'll try to make, if you can make it really quick, we might have room for another.
My name is Alok Guha. I'm with Veritity Software out of Boston. We do real-time energy monitoring at the sub-rack level. So one of the questions I had was, and I'll start with Facebook, that you were doing thermal maps because you have the wireless sensors. do you have a good idea what the actual heat load is at a server level instead of just waiting for the thermal maps to deliver cooling?
Yes, we do. Because as I said, we monitor our each and every server individually. So we know exactly what each server is drawing in terms of load. And that's how we were able to actually match the fan speed control. So we have that data, and we do monitor that data.
Cool. And how about at eBay? Same? Can you actually, because you're using VFDs, do you know at a sub-rack level how much power and heat load is being drawn at a server level?
So we approach it a little differently, not at each individual server, but set our delivery temp, again, at the 7-foot rack level, and again, understanding what's installed in the racks, but monitoring it at 3 wireless sensor points on each rack, and just ensuring that we deliver consistently, again, at the 7-foot level. And so the variable fans, and BMS work in conjunction to maintain that.
Okay, interesting.
Great, thanks for your question. Sir, let's take you in the white shirt there in the back, and that'll be our last question, and then we'll wrap the session up.
Great. Thank you. Good morning. I'm going to take, my name is Gary Cook. I work with Greenpeace International, and I'm going to take maybe a slightly broader look at holistic energy use. And I'd like to say we use very big users of Facebook. All of our offices use Facebook to educate our supporters on our environmental issues we work on. But wondering, and certainly the presentation this morning, I think we've all seen a tremendous amount of innovation in driving better energy use. And critically, in part why we've been engaging with the IT sector for a number of years, we see this sector is playing a huge role in driving innovation, because we're not seeing enough innovation in the energy sector, unfortunately.
Sir, if you can get to your question.
Yeah, sure.
We're
so I guess
Ray,
eBay brought this up in terms of their carbon management strategy. I just would like to put to both companies how you're looking at, once you get outside your data center, how you're looking at responsibility for energy management, and looking at energy efficiency strategy is certainly a big part of it, but also looking at the energy supply. And in the same way you're talking to your OEMs for adjusting your servers, talking to your utilities about adjusting the carbon content of your energy supply.
So I just want to let my panel know we have 30 seconds to wrap this up. So if you prefer, we can give a really quick answer, or I can certainly just wrap up our session with one quick comment to try to answer that as well as I can, just because we're trying to stay on a very tight schedule here.
Could you just wrap it up for us there, Casey?
Okay. All right. So let me maybe address it this way, right? I mean, we're all here to save energy, right? Our industry is growing. It's a fantastic thing. And undoubtedly, as we grow, and we're going to use more energy, and obviously our users, of course, are pushing us through that growth, which is really great. But we're all going to use more energy in doing so, but we're also getting dramatically more efficient. And no doubt about our PUE numbers on average across the industry are getting better. We're all trying to address it through making ourselves more efficient, because that has the greatest carbon net reduction and other environmental impact, and also the greatest, really cost reduction that we have for our companies. So thanks for your question. I'm sorry we couldn't really properly address it. We're out of time. Thank you all so much for coming today. Really appreciate you all being here. Our next session starts in 5 minutes. And yes, please help me give a great round of applause to our folks that are sharing the information today.